Hello guys, welcome to Pepcoding, and today we are gonna solve this question, solve Sudoku. This is a very good question and ideal question for backtracking and recursion. So we will just gonna solve this question, and how we are gonna solve this is there is a flow for that. First of all, we will gonna understand what's the question statement is. After that, we will gonna understand with some example what this question is asking to us, how we have to do it. Okay. After that, I'll tell you the approach for this question. And at last, I'll show you a dry run. And after that, we'll just code this question. This is a very simple approach. The workflow for this video right now. This video will gonna be a little bit long because this question is a little bit kind of complex. But if you do it in a part by part way, this will be a very easy question. So just be with me, and I'm gonna solve you. I will let you solve this question by yourself. Just see this how. So first of all, you can see what the question statement is. You are given a partially filled 9 by 9 2D array, which means I have a 2D array which is a incomplete Sudoku state, which is in incomplete Sudoku state. All right, let me take this incomplete Sudoku state. You are required to assign the digits from 1 to 9 to the empty cells. I have to do what? I have to assign the digits. Okay, with some rules. There are some rules. First is digits from 1 to 9 must occur exactly once in each row. Digits from 1 to 9 never repeated in a row. 1 to 9 never repeated in each column, and 1 to 9 must not occur again in the sub-array. These are the just three rules. And how I know where I have to put my 1 to 9 digits is this. 0 represent an empty cell. And I have to do what? I have to only put my digit in empty cell. So 0 represent an empty cell. We have to assign my digits to the empty cell. Okay. So now let's try to solve this question. First of all, let's get to our open and I will explain you how to do it. So this is the kind of input we have given. We have given this kind of array, right? So here you can see that we have some places where it is 0, right? So we have 0 here, we have 0. Just give me a second, my pen drive is not working. Okay, now it's working. So 0 is here. Okay, it's not working over this board. What is happening here? Check this out. Okay, is it working? Is it working now? Okay, so there are some places which have zeros, like 0 is here, 0 is here, 0, 0, and these are the places we have to fill. And what were the rules? First, no repeat in column, no repeat in column, no repeat in row, and no repeat in sub-array. Very simple rules, right? Now we just have to do these things. Now understand what will be my approach for this question. So I will do what? I will put cells on the label. I will put cells on the label. And how many possibilities are there? I will put that. So first of all, let's check this out. First of all, at the first time we are where we are. We are at 0, 0, right? So we are at 0, 0. I will start my at 0, 0. There is no 0, right? The place is not vacant. The place is already filled with some number. 0, 0. Place is already filled, right? So here I have 9 options. 1, 2, 3, 4. Sorry. At 0, 0, I don't have 9 options. Why? Because this is already filled. So I have to do nothing. I just move to label number this 0, 1. 0, 1. At 0, 1, I have 0. That means I have all the 9 options. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like from 1 to 9, I have all the options at this place. But the thing is, we will gonna check which are the places I can fill. So first of all, let's try to put 1 here. Okay, I'm gonna put my pen like this. Okay, first of all, let's try to put 1 here. Can I put 1 here? 1 is in the row? No. Sorry, 1 is in the row? No. 1 is in the column? No. 1 is in the sub array? No. So okay, I put 1 here and I make my call to 0, 2. 0, comma 2. And there are other options, but if 1 is already there, so I don't have to make any other call. We are at 0, comma 2. Now 0, comma 2, it is written 6. 6, right? 6 is already filled, so we have to do nothing. Move to 0, comma 3. Move to again 0, comma. Here is 0. Now let's try to put my word. So can I put 1 here? Again, there are all the 9 options. I have all the 9 options from 1 to 9. I have all the 9 options. I try to put 1 here, but 1 is here, so I cannot put. Right? So I have all the options here from 1 to 9. So I try to put 1 here. No, I cannot put. Then 2. 2 is 2 here. No. But I can put 2 here, right? So I put 2 here and I make a call to 0, comma 5. Then from 0, comma 5, I have to make a call to 0, comma 6 because I cannot put anything. I think I should put my tree a little bit downward, but it is taking a lot of space. Okay. Right now I'm at 0, comma 6. From 0, comma 6, I go where? I go to 0, comma 7. At 0, comma 7, there is again a vacant place, 0. And I have to put something here. So let's try to put. I also have all the options. Like I have the options from 1 to 9. I have all the options. So let's put 1 here. But 1 is here. 2 is here. 3 is here. 4 is here. 5 is here. 6 is here. 7 is here. 8 is here. 9. There is no 9. So let's make a call to 9 and move to 0, comma 8. Now at 0, comma 8, just think about it, is if 7 is written here. Now try to just give me a second. Now try to make a call to 1 to 9. Like I have all the options to 1 to 9. So let's try to make a call to 1 to 9. So can I put 1 here? No. 2 here? No. 3, no. 4, no. 5, no. 6, no. 7, no. 7 is already filled. 8, no. 9, no. Now the options are left. At 0, comma 8, I have no options to do anything. So what I will do is understand this now. This is the point of understanding. We come from here in such a way, like we come from in this way, we came here, and here I got my options left. Now what I will do is I will do backtrack. I will check other options. So if I go here and one more thing, I have to remove my footprints. So I have to remove 9 from here and I need to put 0 again back to here. I put 9 and I check if there is any other options I have rather than 9 at this point. No, this is the last position of 9. So I have to do more backtrack. At 07 nothing, at 06 nothing, at 05 nothing, at 04. At 04 I have written 2. So all that, first of all remove this 2 and check if I have any other options here. So let's check what are the options I have at 0, 2. So 0, 4. So I cannot put 1 here. I cannot put 2 here. I cannot, sorry, 2 is 2. After 2 I came, so I start my checking from 3. Can I put 3? No. 4? No. 5? No. 6? No. 7? 7 looks like a perfect match. So all right, next call I make to 7. From 7, okay, next call I make to 7, and after putting 7 here I go to 0, 5. At 0, 5 again I do nothing. 0, 6 again nothing. 0, 7. Now check it out. Can I put 1 here? No. 2 here? No. 3 here? Sorry. Can I put 0, 7? I have to make a call to, like, at 0, I have to come at 0, 7, right? So can I put 1? No. Can I put 2? I can put 2 here because 2 is not in the row, 2 is not in the column. So let's make a call to, from 0, 6, from 0, 7 I put 2 here, and I make a call to 0, 8. At 0, 8 let's check. 1, no. 2, no. 3, no. 4, no. 5, no. 6, no. 7, no. 8, no. 9, yes, 9 can be put here. So now you understand how we will gonna do it, right? We will check we have to check every possibility. So what we will do, we will check if there are some ways to do it. First point is we have to understand this. First of all, we have to check if the place is vacant. If the place is vacant. Then I have to check for all possibilities. Possibilities. From possibilities, I have to check for contenders. Contenders means I have the possibility from 1 to 9, but all are not valid. Contenders, or I can say valid, which are valid. Then I have to do what? I have to make my recursive call. Then I have to put my digit. After that, make a recursive call. That last, I have to do what? Backtrack, or I can say remove footprint. So now we're gonna do these things, just these things, and this is very simple, right? These are simple things we need to do for this question. Now let's get to the coding part, and we will gonna solve it in Java. So we have given a 2D matrix ARR, and I just have to do this part of the code, solve Sudoku. So here, first of all, what I need to do is I need to travel through this matrix. So how can you do it? First of all, I will make two variables for that. I'll do what? Int new I is equal to 0 and int, and then int nj, that is equals to what? 0. So this is new I and new j, or I can say new row and new column. These are two variables I take just for the traveling part. Now I will make some conditions. I will write some condition. I will explain you later. Just be with me. I will write if j is equal to board dot, or not board 0 dot size -1. I have to do something, else I have to do something. Then again, if board of 0 not say 0, board of I and j, is equal to, or I'll say is not equal to 0. If if not equal to 0, I have to do something, else I have to do something. So right now there are two conditions: if else, this if else, and then this if else, and both represent a very different thing. First of all, this if else is for what? This if else is for updating row and column. What? Updating row and column. And this if else is for recursive calls. Right, now updating, why I need to update row and column? So let's see here. We have given this, okay, just move there, right? So we have given this kind of matrix, right? And we have to move through this matrix. We have to travel through this matrix to check to check every possibility at every possible place. So we have to move from here till here. The thing is, how we will gonna do it? This is the main thing. So if we are at this place, what we will do? We have to move one more at the column part. But what if we are here? If we are here, what we have to do is just j plus plus. But if we are at this place, what we need to do is we need to come to here. So we need to do what? Row plus plus, but j is equal to 0. These are two things we need to check and do. The first condition was for that. If we are at the end, what we need to do is we have to move to next row. So ni is equal to I plus 1, and we also have to make our j 0. Else we have to do what? We have to remain at the same row, but nj is equal to j plus 1. We have to move our column. Now comes the recursive part thing, that if we are at a place where there is no zero, there is no place backend to put anything, we just have to make our recursive call and do nothing. Solve Sudoku board, comma ni, comma nj. After this, we have to go to this else part, where this is where we have to do everything. Here I again write a I have, first of all I have to check for every condition, right? So for int value is equal to 1 to value is smaller than equals to 9, and then value plus plus, right? Now you have to check board, not board, I have to check if this particular value is even a contender or not. These are what, these are all possibilities. Now I have to check for contender, that what are the valid, right? So I have to write is valid function, is valid, and what I have to put here is board, comma I, comma j, comma value. And if this is valid, I need to do what? I need to place my digit. Board of I and j is equal to value. Then I have to make my recursive call. Solve Sudoku board, comma ni, comma nj. And at last I need to do what? Board I, comma j is equal to 0. Why we did at last board I, comma j is equal to 0 is for the backtracking, removing our footprint part. Because we need to remove our footprint, right? So at that part we need to do what? We need to make our board again 0. So these three lines are the main line. First of all I have to check board is equal to value, and here I have to do again this. So first of all I have to check if this is a valid value or not, then I have to put that value, and at last I have to remove that value, and in between I have to make a recursive call. This is done. Now let's move to our is valid function. That is also a very easy function, just be with me and it will be done. We have to make it in boolean, so boolean, and make it a public boolean is valid. I have to do what? First of all, let's take our board. Int board, comma int x, comma int y, comma int value. Okay, these are the things I have for is valid, right? Board ij value, right? Now I have to do some things. First of all, let's check for horizontal part, that if horizontal part is perfect or not. So I have to write my code as equal to 0, I is smaller than n. Let's make it a, so int n is equal to board dot length, right? Here also I have to like length eth, because this is Java, this is not C++, so I have to write length here, not okay, everything looks fine now. Okay, so int I is equal to 0, and I have n, so it's smaller than n, and then again I plus plus, right? Now here let's check this out, that if board at what place, this is x is what for row, and I for column is what? Variable. If x and I is equal to value, if I get my value, what I need to do is return false, right? This is for what? Vertical. Now let's try to make for horizontal as well. And here I need to do what? Make, sorry, this is for horizontal and this is for vertical. Now I and what? Y will be same and I will be variable. So this is for what? This is for vertical. Now let's move to subarray part. Subarray, this is a little different, so let me tell you the concept of this subarray thing. Okay, so remove other things first and then I will explain you this subarray part. This is also an easy part, not a big thing. Okay, Okay, remove this also. Okay, guys. So 0, 1, 2, 3. Now understand some things, like let's take this is how many subarrays are there. So this is how many subarrays are here. So understand, this is a subarray, right? And again this is a subarray. All the subarrays with 3 by 3, right? This is the subarray. And again this is a subarray. This is a subarray. And this is a subarray. Now at last, this is a subarray. Okay, my pen tab is not working in this place, but no problem. This is a subarray. These are the subarrays, right? Right, guys. Now understand. If I take this value, if I take this one, this place, like 4 comma 5, 4 comma 5, and I did what? I did 4 divided by 3 and into 3, and 5 divided by 3 and into 3. So I get what? I get what here? 3 by 3. 3 by 3. And 3 by 3 is which number? 3 by 3 is this number. Now understand what I want to achieve here is, if I get these coordinates, corner coordinates of every subarray, I can travel through that subarray, right? If I get the corner coordinates of that subarray, like if I get any digit from any coordinate from this subarray, and from that subarray, from that digit of subarray, I can extract the coordinate of this corner point. I can get travel through this subarray, and I can check if this there is a value something like this or not. If I can get if that value is valid or not, right? So for now there's a formula, which is I just need to do what? I need to divide by 3, multiply by 3, and divide by 3, multiply by 3. This is just we need to do, and from there I get my corner point. Corner position. From corner position, I can travel through that corner position to the subarray. I can check. Let's do this by our code. So in subarray part, I need to update. So first of all, x is equal to what? X by 3 multiply by 3. And again y is equal to y by 3 multiply by 3. These are the things. Two things are done. Then I have to do for int I is equal to 0, I is smaller than 3, I plus plus. Again for int j is equal to 0, j is smaller than 3, j plus plus. Now we have to check if board of something is equal to value. If I get the value, I have to return what? I have to return false. But if I never get that value, what I need to return? Return true. Return true. Very simple. But what I put here? Here I have to put what? X plus I and y plus j. Simple. From this formula of divide by 3 multiply by 3, I can do what? I can get everything. I can get the corner point, and from corner point I just have to travel through that subarray, and I check if there is that kind of value present or not. If there is no value present, then I have to return what? True. That this is the valid position. So in this valid position, you have to just do this. Now there's one more thing left, guys. Here's I did the recursion part, but I have to put a base case, right? So what is the base case? If I is equal to board dot length. Board dot length. If I have reached there, I need to do what? I need to display board and return. Right? This is done. Why? Let's understand this base condition also. The base condition is what? At some point in time, I will reach to this position, this 0 position. This is 8, 8 position. And when I reach to 8, position, I have to do what? I will return to this position. This position is what? 9, 0. So if at any point in time my row number get equals to length, that is what? The termination point. Termination point. This is what I did. If my row number reach to length, I just terminate, return. Right. Now let's try to run this code. If there is any problem, compilation error, we're gonna solve it. Other than that, I think everything is working fine right now in this code. There is a compilation error. Method is valid, right? It is saying you cannot access method is valid from the static context. Very right. Is valid is not static, I guess. Public let's make it static also. Static. Public static boolean. Again, then this code. Answer is kind of wrong, so let me check where we are wrong. Alright, so this is the wrong answer. Let me check again. id is equal to board.length, and I is equal to 0, and j is equal to 0, j is equal to board minus 1, and I is equal to I plus 1. And yes, guys, there I have to update new j, right? This was something very silly mistake, but still sometimes happen this coding. So let's run this code again, and I guess this time it will work fine. Accepted. Now try to submit this code. Okay. Correct answer. So guys, if you understand the concept behind this question, if you understand everything, if you understand how we can solve Sudoku, how to apply the backtracking, how the question work, please like the video. If you have any query left regarding this question, please subscribe to it. Please comment it out and subscribe to our channel. Thank you so much, guys.